Hello friends, welcome to engineering tutorial. In the previous video, we discussed some of the basic introductory concepts related to network models. We discussed the basic definition, a real life correlation about the working of a network model, where we discussed the postal communication system example, and we just discussed the two popular network models that are generally used in network connections. So the first one was the Open System Interconnections model, and the second one was the TCP/IP protocol suite. So in this video, we are going to discuss about the Open System Interconnections model. Okay, some of the basic concepts related to it. So the OSI model, or the Open System Interconnections model, is a network model. Now we know what a network model is. Okay, again, if I want to repeat it, so the network model is a basic framework, okay, associated with each device, each node involved in the network, which is divided into several layers, several levels, and the data or the information which has to be transferred in the network has to pass through all of the layers, all of the levels. It has to be passed and processed through each of the existing levels in the network model. That basic architecture, that basic framework. Okay, so the OSI model, it is the acronym for Open Systems Interconnections. Again, it is a layered framework. Okay, the basic definition of network model itself states that it consists of several layers, several levels. So the OSI model, being a network model, has a layered framework, and that layered framework in the network system allows for communication between all types of devices or nodes. Now, the OSI model was first introduced in the late 1970s, and what it actually is a set of rules, set of protocols, network protocols, that allows two different devices, two different nodes to communicate regardless of their network architecture. Now, there are certain important features of OSI model, okay, distinguished features of the OSI model, and those features are: first one is the layered architecture, second one is peer-to-peer processes, and third one is the interfacing between layers. Okay, so let's discuss them one by one. First one is the layered architecture. Now we know that when communication takes place between two devices, there is essentially transmission of data from one point to another. Okay, and as per the network model, the data has to pass through the several layers of the network model architecture, and the layered architecture in the open system interconnection model, it actually consists of 7 layers. Okay, 7 layers. Okay, so these are the 7 layers of the OSI model. We discussed them in brief in the network model video, but these are the 7 layers that are present in the open system interconnection model. So starting from the top, the seventh layer is the application layer, and there is a gradual top to bottom flow of data when it is passed and processed through each device. Okay, starting from the top, that is the seventh layer, to the bottom, or the first layer, which is the physical layer, from application layer to physical layer. So the first layer, starting from the bottom, is the physical layer. The second one is the data link layer. The third one is the network layer. The fourth one is the transport layer. The fifth one is the session layer. The sixth one is called as the presentation layer. And the seventh one is the application layer. Now, each of these layers perform a specific task which is involved in the transmission of data and the processing of data as it passes through each of these levels, starting from top to bottom. Again, I repeat, the direction of flow of data in these layers is from top to bottom, from application layer to physical layer, and each layer calls upon the services of the layer just below it. Okay, so as I said, each layer serves the layer which is just above it, and each layer uses the services of the layer just below it. Okay, so the physical layer serves the data link layer, the data link layer serves the network layer serves the transport layer, the transport layer serves the session layer works for the presentation layer, and the presentation layer works for the application layer. So you can correlate it with the management hierarchy that exists in the organizations. Okay, there is the topmost level, there is a middle level, and there is the bottom level. Okay, each layer as we move upwards and upwards becomes more and more superior than the layer just below it. Okay, so this is what the layered architecture is. The next feature, which is the peer-to-peer process. Now what this peer-to-peer process means is that each layer in the OSI model, it communicates in a particular device. For a particular device, the OSI model, each layer interacts or communicates with the same layer of the other device or node. Okay, for example, in a communication between two devices, let's say device A and device B, the transport layer of device A interacts or communicates with the transport layer of device B. Okay, there is communication taking place between the transport layer of device A and the transport layer of device B. Okay, similarly, the physical layer of device A can communicate only with the physical layer of device B, which is the bottom layer, the bottommost layer. Similarly, the application layer of device A can communicate with the application layer of device B. Okay, so it cannot be that the application layer of device A can communicate with the transport layer, or the transport layer of device A can communicate with the physical layer of device B. There is no cross communication. Okay, there is only parallel communication taking place between similar layers of two devices. That is what peer-to-peer process means. Okay, each layer interacts with the same parallel layer of the other device. Transport layer with transport layer, application layer to application layer, physical layer to physical layer. The third feature which is involved in the OSI is interfacing between the layers. So in between two layers, okay, as there are 7 layers present in the OSI model, in between two layers there exists an interface. Okay, in between two layers there exists an interface. Okay, and what this interface does is that it helps in the transmission of the required data and information from one layer to the other. That interface serves that purpose. It sends the data, the required data, from the data link layer to the physical layer, as there is a top to down approach. Okay, So the sending of data in between the two layers, the sharing of data between the two layers is served by the interface. Okay, and each of these layers has interface in between them. For example, here there exists a 2 to 1 interface, that is from data link layer to physical layer interface between layer 2 and 1, that is a data link layer and physical layer. Similarly, between the transport layer and network layer, that is layer 4 and 3, there exists a 4 to 3 interface. Similarly, in between the application layer and the presentation layer, which is layer number 7 and 6, there exists an interface which is called as 7 to 6 interface. And all of these interfaces perform one task, that is sending the data from the layer which is at the top to the layer which is just below it. Okay, as there is a top to bottom data flow direction. So again, to be clear, the data flow direction or information, the flow of data and information which takes place while communication between two devices, from the sender, which is, let's say, device A, which is the sender device, the data flow, the processing of data starts from the application layer of device A, then it goes to the presentation layer, then it goes to the session, to transport, to network, to data link, to physical. Again, at the receiving side, that is device B, it gradually moves upwards. Okay, in the receiving side, it gradually moves upwards. This is the direction of data flow. From the sender side, it is top to down, okay, up to down, and in the receiving side, there is a down to up approach. Okay, there is a down to up approach. So from the sender side, it is up to down approach, and in the receiver side, it is a down to up approach. From bottom to top, here it is from top to bottom, here it is from bottom to top. Okay, so this is the direction of the data and information flow in the OSI model. Okay, in the receiver side, the data is processed from the top to bottom, from up to down, from application to physical. In the receiver side, the direction is from bottom to top, from up to down, from physical to application layer, and the data is transferred, is processed between each of these layers that are in between them through the interfaces. So this is some of the basic concepts related to the OSI model, and the three essential features of the OSI model are layered architecture, peer-to-peer processes, and interfacing between layers. And the last one is the very important one is to remember the flow of data and information in the OSI model. In the sender side, at the sender side, the data flow direction is from up to down, and the receiver side, the data flow direction is from down to up. Okay, from bottom to top. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.